speak quickly and make it short. So this session is about sustainable material solutions. My name is Wolfram Schmidt, and I will chair this session. I would like to ask you to ask a lot of questions, ask them in the chat. Maybe you give your name and then you ask the question in short, and after the session, depending on how much time we will have, we can give you the microphone and the camera to ask the question yourself, or if there's only a little bit of time left, maybe I will read the questions from the chat. But now let's discuss about sustainable materials. We have a lot of options here, and the question is always, what is a sustainable material? And the answer is very difficult because all materials have their pros and cons. For example, timber has become kind of fashion again these days. It's advertised, and certainly timber construction is very sustainable as long as the timber comes from sustainable sources. But the problem is certainly that in the entire world, we don't have enough timber to meet the global construction demand. And in some areas, particularly in East Africa, you can see this, and also in the southern East Africa, Malawi, for example, there are huge environmental damages due to the deforestation. So timber is not entirely good. It depends on where you can source it. And then steel is another aspect. Steel certainly has a dramatically high carbon footprint, but then again, if we use recycled steel, it's getting much better. For example, here you can see how virgin steel compares to recycled steel, and the recycled steel is very similar to other construction materials. Still, certainly, to a certain extent, it makes sense to avoid steel, but then again, steel has outstanding properties, so we cannot avoid it where we have tensile loads. There is no better choice than steel, so we always have to make a good selection. Then earth materials probably are those materials with the lowest carbon footprint. They really have a remarkably low carbon footprint, and they can be used all over the world. But there's a challenge with it as well, because they require maintenance. For example, this wonderful mosque in Jenné is being maintained once in a year in the course of a celebration that is taking place, where people celebrate and at the same time maintain this mosque, which makes it sustainable, but only due to the regular maintenance. And because of that requirement, people often use cement stabilization in earth materials, which is really not good, because you use more or less the same amount of cement for the same volume of construction materials, but the compressive strength value is extremely low compared to real concrete structure. So cement stabilization of earth materials is also not the best selection. And then we have concrete. Concrete certainly causes a lot of global carbon emissions, basically due to the use of cement, but mostly because it's used in such a high amount. Its carbon footprint is typically much better than most other construction materials. You can see this in this figure on the right side. And it has some outstanding properties that other materials cannot compare with. It is doable everywhere. It always fosters the local economies. It is easy to handle, and it's also reasonably cheap, even though this is not entirely true for the African continent. So what we can definitively state is that from all those choices that we have, there won't be a simple solution. There won't be a single, not an all-for-one solution, and the solution is not falling from the sky. So there won't be a marble solution. Probably a good approach is to use a hybrid way of construction in the future much more often. But what we can state definitively that in terms of availability of materials, concrete is the only material that we can use to meet the global demand for construction materials. And this is a fact whether we like concrete or whether we are against it. But in the course of the urbanization processes that will take place over the course of the next decades in Africa, concrete will definitely play a major role in that. And we have established something like a worldwide, generally agreed upon best practice, some codes, regulations, which everybody accepts more or less. But we also have to consider that most of those regulations were kind of inspired by the environment of the Northern Hemisphere. And often these best practice regulations, they ignore a little bit Africa's specific items like geography, geology, the history, the culture, the vast diversity, and also the huge dimensions of that continent, and also certainly the climate. And that is an issue. And I would just like to give a few examples. Ready-mix, for example, is considered to be very good, but you can hardly find ready-mix. And if you take a look at cities like Lagos or Dar es Salaam or Douala, there's always traffic congestion, so ready-mix concrete won't be a solution. Maybe there's potential for innovation by using ready-mixed, dry mix mortar compounds that already contain plasticizers and probably sand, just to be added by water and aggregates to make concrete more doable on the construction site, more robust. And then in most of the Northern Hemisphere countries, the driving force for construction is the maintenance of structures. But in Africa, there is really a need to build new structures that do not exist yet. So innovation in construction materials is required. And since there's also a growing market for cement and concrete, those innovations can directly be adopted because customers will need it. But there's certainly also a challenge because cement prices in Africa are extremely high compared to other regions in the world. Not though in absolute prices, but if you relate it to the purchasing power. For example, here in this figure on the right side, you can see the number of working days for an average income earner to purchase 1 ton of cement in a local framework. And in the United States and in Germany, this would be half a day only. But in the Democratic Republic of Congo in 2009, it was 323 days. So this is really like building with gold. It's getting better, but certainly even 150 days in 2018 is still too much. So there's a lot to do, and we need to find ways to save cement and make cement more efficient in concrete. This can be done by chemical admixtures, which to date are typically processed somewhere outside Africa and then shipped into Africa at a high price. But the potentials in Africa would be bio-based solutions, polysaccharides. They can be locally harvested, locally processed, and they can also be used as excellent and sustainable superplasticizers, for example. And then all those established cement replacement materials such as fly ash and slag, they don't exist on the African continent. So alternatives would be bio-based materials, for example, or also calcined clays, for example. But for the bio-based industries, there's a lot of growth potential. Here you can just see a figure of the percentage of the total cement market in different countries, which are listed here, and how much of the total cement in the market could be replaced by bio-based reactive ashes to replace cement. It's not that much, like 6%, 5%, 4%, or 3%. But the interesting thing about it is that the agriculture has a huge growth potential in Africa, and also the yield per hectare is relatively low compared to other regions in the world. So there's a huge potential to grow more and more agricultural crops, and from there resources for concrete construction. For example, here you can see a cassava-based concrete, and here you can see a normal concrete. The color is different, but the mechanical properties are similar. And then certainly African architecture is also unique, and that can create a new field of research where you try to better find materials and structure relations. And I think that is also potential for the future, where a lot of innovation can be driven coming from Africa. But then there is this major challenge of the durability. The climate is challenging, it's humid, it's warm, there's a long coastal line, there's a lot of chlorides, which can cause corrosion. So the aspect of durability is key in concrete research in Africa. So what is important to make sustainable materials is to get it from sustainable raw materials, to find sustainable processes, and also to make materials durable. That is the most important aspect, and interesting enough, we have exactly speakers that are experts in this area. The first one is Dr. Kolawole Adiza Olonade. He will talk about bio-based cement replacement potentials in Africa. The second speaker is Professor Manus Hantanam, and he will talk about future cement solutions for tropical climate conditions. And the last speaker of this session is Professor Mark Alexander from the University of Cape Town, and he will talk about specific African durability challenges. And now, without further ado, I would like to give the word to Dr. Kolawole Olonade with the first talk on bio-based materials.